session. Mr. SumitPatel completed his BTech in Mechanical Engineering from JSS College, Noida in 2016. After that, he has worked in multiple startups, which worked in the blockchain space since 2016. He has worked on different blockchains, including Bitcoins, Ethereum, Hyperledger Fabric, Quorum, etc., and has developed multiple applications on them. As of he is working at IIT Kanpur as a project engineer on National Blockchain Project under the supervision of Dr. Sandeep Shukla. Over to you, Mr. Sumit Patel.
Thanks for introducing Mega. Is my voice audible to everyone?
Yes, it's audible. You can go ahead.
Okay, I will share my screen.
Yes, sir.
So thanks all for joining the meeting, and today we will be studying about like how do smart contracts work on the Ethereum blockchain, and what is an Ethereum blockchain, and what is the use cases of smart contracts that we can use it on our daily life and build applications on it. Like, so I am basic. Hello. So yeah, so we will be studying about like different smart contracts that can be created, and at the end we will be also showing some demo of smart contracts, how to write a smart contract, how to identify different functions and different requirements in the smart contract. So I will start first with like what are smart contracts. So as of now, you may know that the popular Bitcoin cryptocurrency started in back like about 2008 or 2009, and after few years of that, the Ethereum blockchain came out of. So, but the main difference between the Bitcoin and Ethereum was the support of smart contracts. Ethereum blockchain doesn't supported the smart contracts, so this was a like major disadvantage that was removed in the Ethereum blockchain. So a smart contract is like just a computer program or a transaction protocol, you could say, that runs respectively, which is intended to automatically execute, control, or document respectively legally relevant events and actions according to the terms of contract or an agreement or a negotiation. A smart contract does execute by itself, so you just have to write the requirements and the code, so it will happen automatically. There is no mediator needed in case of the smart contracts. So whenever we write a smart contract on Ethereum blockchain, there are different tools and languages available as of now. So as you may all been familiar with the Ethereum blockchain, like it is the second most used blockchain all over the world. And with the inclusion of smart contracts into the Ethereum blockchain, made it wide popular. The ICOs, that is similar concept to the IPOs, has helped many small companies to raise a large amount of sum for the development or for their startups, so that they could raise funds from different persons across the world. So this ICO is just similar thing of IPO, and these all the ICOs were done, 90% of these ICOs were done on the Ethereum blockchain only. And with the help of these smart contracts, like many companies were able to raise like few hundred millions and few $billion with the help of these smart contracts only. So as of now, you may be thinking like, where could we use these smart contracts? The smart contracts can help you in the exchange of money. Like if you want to exchange money from one part of another part, one person to another person across the world. It could help you to share your property and anything that you want to trade from one person to another person. The most advantages of smart contracts is that they are very transparent and they are very conflict free, and that doesn't require any middleman to come in between and do any action. Once you write the requirement or functions in the smart contract, it will execute it by itself only. So now we'll move to the next slide. How does the smart contract in Ethereum work? So mostly the Solidity language is used, which is some kind of similar to JavaScript only. So people who are in the computer science background have worked upon the JavaScript can easily work on with the Solidity and start writing the smart contracts on the Ethereum blockchain. So smart contracts in Ethereum include like different functions, which are like some modifiers, function to set a value, function to get a value, and all these code, once you write a specific code, that code is installed or resides on a specific address. Let's say I wrote a program or a smart contract that takes input of a name and fetches me the same name. So that smart contract will be including two functions. One function would be to store the data and another function would be to get the data. So once we deploy that smart contract on the Ethereum blockchain, so it will be having a specific smart contract address that would be like unique identifier for that smart contracts. So in order to interact with that smart contract, you need that unique identifier, because without that you couldn't identify like how would you interact with it and how would you process the different functions including it. So whenever we want to interact with the smart contract, we take the help of this unique identifier, which is the smart contract address, and the code which is written in the smart contracts. Once it's processed, it's all over the Ethereum blockchain. So each and every node that is running the Ethereum blockchain has your smart contract code. So the whole network processes your information and then calculates the value. Let's say you made a function to store a value and get a value. So whenever you store a value, the whole EVM Ethereum blockchain processes it, and then whenever you want to get it, the Ethereum blockchain again processes the whole information, identifies the contract with its address, and fetches you the information. This contract does not much store like images, or you could not store like large files such as like movies or video songs or something sort of that, because to make a transaction or to make a smart contract, you need to pay some fees, and that fees is the gas fee which keeps the running network in the Ethereum blockchain. And the fee is paid in the form of ether, which is the token on the Ethereum blockchain. So ether has like some value in US dollars. So as of now, I think currently one ether is valued approx $120 or $150. So to make a very small transaction, the ether value or the gas value can cost you approx like $0.01 or $0.1. So as you increase the limit or the size of the smart contracts, so the gas value or the cost to deploy a smart contracts also increases. Suppose you build a smart contract which stores 1 MB of any music file or anything that you wanted to store on the blockchain. So it can cost you approx $10 to $20 to store that thing and to make a transaction on the network, because the Ethereum blockchain is not meant by the way that it would store like huge chunk of data. So they are just meant to store the numbers. So it is always preferred to store a reference of that data in your smart contract, or something very of a small size that doesn't cost you a lot of ether while making any transaction. So once you make a transaction, once you store the data in the smart contract, then you could access it from anywhere. Then it's like not all the nodes in the Ethereum blockchain would be having it. So there is very less possibility that you will be losing your data. The only thing that you need to get your data is your private key. So whenever we make a transaction, we do need a public address from which we can make a transaction. In order to make a transaction on any smart contract, we need to have like few amount of ether to make a transaction, because whenever we make a transaction, it will check that your address has a sufficient amount of ether in it or not. If you don't have sufficient amount of ether, the transaction will not be successful. So this is the main thing to keep in mind while like developing a smart contract or while making a transaction on the Ethereum blockchain, that you have enough amount of ether to make a transaction. But if you are developing in the like local development or local testnet or the local environment, then you could set up your the local Ethereum blockchain, which is Ganache, and make the test transaction on it. Then it won't be costing any ether or something of it, because everything is in the test development. So the ether would be having the zero value, so you could generate n number of ether and test the whole smart contracts on your local blockchain, and then start the development. Once you have completed all the testing process on your local development, then you could move the your smart contract to the main Ethereum blockchain. So Ethereum has provided different test nets to test your smart contract, so that you don't need to pay again and again for making any transaction or for making any errors. Because whenever we develop any program or anything, we keep coming of different errors in the program. So until unless all the errors are not removed, we keep debugging it and we keep removing it and we keep deploying it again and again. To remove this thing, in this Ethereum blockchain, the Ethereum Foundation has provided us with the different test nets. So there is like three test nets. One is Robston and one is Rinkeby and another is Ganache. Ganache is the local test net that you would set up in your local. And Robston and Rinkeby are the overall test nets that you could connect anytime and run the smart contracts. So once you publish your smart contract on the Ethereum blockchain, you could like easily access it from anywhere till you have access to the connection to that blockchain. Next, we will move like why there is a need for a smart contract. Like why do we even need the smart contracts? Why can't a simple function in Node.js or JavaScript, or you could say C++, make this thing instead of this smart contract? So first thing that we need, that the smart contract provide, is the autonomy. Like you don't need to rely on any third parties. So if you are writing any function or any program in the C++ or Python or Node.js or JavaScript, you need some third person to make the calls. But in the case of smart contracts, you could make the actions independent of the third party, that there would be no requirement for the third party. Things can happen on its own. So let's say you make a function that would transfer my money from one user to another user after the 20th day. So if you write this program in the JavaScript or C++ or Python, you would need someone to click the buttons and then make it the transfer. But if you go with the smart contract, you could fund both the user address. Like if you want to transfer from user A to user B, you could fund the user A address and write the smart contract that after the 20th day from today, transfer my tokens from or the ether from user A to user B. So once you write this smart contract, it will automatically transfer from user A to user B once you provide the valid authentication. And authentication in here means private key, so that you are allowing the smart contract to act on my behalf, so that it could transfer the ether from one party to another party. This is the first benefit of the smart contract. Second benefit that we came across is like the trust. Blockchains are very popularly used for this is to building the systems that need trust, because in today's world we lack the trust part in all the systems. So let's say I'm sending any document from person A to person B. How do I kept ensure that like my document isn't revealed in between? How do I ensure that my money is safe with you? And how do I ensure that I transferred some money from party A to party B. So let's say you made the transfer from the party A to party B. There would be like proper valid proof suggesting or validating that user A transferred 10 ethers or 10 tokens to the user B. So everything is public in case of Ethereum because Ethereum is a public blockchain. You could go to the Ethereum block explorer, which will be, and enter your address, and it would show you the amount of transfers that are made from your account and the amount of token that you hold in your address. So this is the second point or benefit of the smart contracts. Now we'll be moving to the third part. The smart contracts are self-executing, so you don't need anyone to keep monitoring them. Like, is this function executed or not? Is there any error or not? Will this function execute or not? So once you write the smart contract, you are free to they are free to execute on themselves. Then fourth point that we came across for the benefits of a smart contracts was the transparency. Transparency means like Ethereum blockchain has a very high level of hash rate. That means that whenever you make a transaction, there are number of confirmations. Like let's say six confirmations or 12 confirmations on any transaction. So let's say user A transferred 10 amount of ether to user B. So if there are six confirmations or 12 confirmations on the transaction, we assume that this transaction has been permanent and cannot be reverted from its stage. So that user B can't deny or refuse that he doesn't received this amount from the user A. And there would be proper time stamp for each and every action that you make on the Ethereum blockchain. So let's say you make a transaction in the morning and it gets received to the user B after few seconds. The user B can't refuse that he doesn't took the money or he didn't receive the money because the address that you sent money to was the user address B. So you could show the proof to that person that I have transferred this money to you, and this is the whole transaction details, and this transaction or the is being confirmed on the Ethereum blockchain. Next, we will move to the smart contract resources. Like how could we write the smart contracts? What are the different tools that are used to write the smart contracts? As you can see that Solidity is the most popular language to write the smart contracts. There are other popular languages like Viper, and in recent developments, Ethereum Foundation has also started to offer the development of the smart contracts in the Python also. So, but like 90% of the smart contract that you will write or that you will come across will be written in the Solidity language only. So any person who has worked upon JavaScript or C++ can start reading their documentation part and start with the development like within a week or 2 weeks. Next thing that you need or require is an IDE, like integrated development environment, such as like you whenever you write some code, you have your Visual Studio Code or Visual Studio, which like debugs your code, helps you to debug, helps you to run your code. But in case of this smart contract, we do have the Remix IDE. Remix IDE is an online platform. Like you, if you enter Remix ID on the Google search, you will be redirected to it. Like you will get the first result related to this query, and then you could write your smart contracts and then deploy it on the Ethereum blockchain and Ethereum testnets and test it and then deploy it to the main network. The third tool that we came across is like the Truffle. Truffle is an tool developed by the Open Zeppelin Foundation. It's a open source tool that is used to test and deploy the smart contracts. You could deploy the smart contract to any test network of the Ethereum blockchain or the main network of the Ethereum blockchain. What Truffle provide is like whenever you have like long smart, very long functions or very long smart contracts, you could write it, and instead of doing it manually, you just write the script and deploy the whole smart contracts in the one go. They are also very helpful to debug the smart contracts. You could write the test cases which will automatically test that if your smart contract is passing or not all the test. If it fails, it will notify you that your smart contract function is failing at this stage. So you could like improve it or debug it and remove the error. Fourth is the Open Zeppelin Foundation, which is an open source foundation, and they have built a very like vast set of standards of the smart contracts. So whenever you need to deploy any smart contract, you could look at to their website, their GitHub repository, and they have like very long list or very well sorted list of the smart contracts that we could refer to. And like most of the organizations keep referring to their smart contracts. They have built very useful libraries also, which are very helpful in the development of smart contracts. Next, we will move to the type of smart contracts. Like now you could be thinking like we have studied about like what is smart contract, benefits smart contracts, and how can we deploy the smart contracts. Next is the like what are the types of smart contracts. So there are majorly two types of the smart contract. First is like deterministic smart contract, and the another is non-deterministic smart contract. Deterministic smart contracts are those smart contracts that do not depend on outside information. That means they are like independent of the whole other environment. They have sufficient information on its own. So let's say you build a smart contract that takes the input of the two numbers and gives you the sum of their numbers. So this type of a smart contract is called the deterministic smart contract because they are not dependent on any other information. You could just provide the input and they will process you the output. So for this, an example could be like peer-to-peer lottery system, where you could deposit the funds on the smart contracts. There would be a single address that would keep the funds that are coming in the lottery, and it will generate the random numbers based on its algo, and then whoever will be having that selected number or the selected number of the lottery will be rewarded the award to his account. So this whole function does works by its own. You don't need some third party API or some third party data to fetch into this smart contracts. Every function, everything that you see in this function will be happening on its own. You just have to write the proper function and code for this and deploy it on the Ethereum blockchain. Next type of smart contract is the non-deterministic smart contract. Non-deterministic smart contracts are those that do not have sufficient information to make their decisions. So let's say you want to build a smart contracts or deploy a smart contract that can pay the farmers of a particular city based on the temperature or the weather conditions of his or her city. Suppose you write a smart contract that if the weather storms or the temperature rises above the 50-degree in Delhi or somewhere near part of that, please reward the farmers enrolled in this smart contract as one ether to each and every farmer. So we could take the info in this whole smart contract. We would need outside information, which is like the temperature or the weather of that city. So in order to fetch those details, we need the help of oracles. Oracles is some other part outside the smart contract, like they act as an independent organization, or you could say beacon, that transfer you the trusted data. So there are various companies that have been started in this field. So what they does is they only provide the trusted data to the smart contracts, so that anyone developing the smart contract can take help of those oracles and get the input to those APIs to their smart contracts. So next we will start with like how can you start writing the smart contracts. First prerequisite for this would be like you should be have familiarity with this Ethereum blockchain and how it works, how it processes the transaction, what are the different components, and how the transaction process, how money transfers, how the EVM works. EVM means Ethereum Virtual Machine, which is the like core functionality of this Ethereum blockchain. And then second part you would needing is some familiarity with the JavaScript, because in order to write smart contracts in the Solidity, the some functions have been taken from the JavaScript itself. So if you are very well aware of the JavaScript, you could start writing the smart contracts in a week or two. So we will start with the smart contracts, like how, what are the main components of any smart contract. Suppose you are writing a smart contract. So how will you start any smart contracts? So whenever you write any smart contract, the extension used for that is .sol, because you are writing the smart contract in the Solidity file. So give the name to the smart contract whatever you want, like my function 1, my function 2, my function 3. Then give it the extension as .sol. So .sol refers to the Solidity file. Once you have given this nomenclature to the smart contract, you could start with the first line. That is very, very important in every smart contract and is required to mention, like Pragma, Solidity, and the Solidity versions. What Ethereum Foundation has done is like they have started quite a few years back. So by now the Solidity language has evolved very much. So they keep upgrading the versions of the Solidity. So they started with 0.20 and now they have moved to 0.60. So the stable version that we use generally is 0.50 only. So pragma word here tells that the smart contract is using the Solidity version of 0.50. Suppose if you are using any previous versions like 0.40, 0.45, 0.4.25, then you could mention on the first line itself that this function or this smart contract will be using this version of the Solidity. So this is very important in every smart contract. If you are not like haven't mentioned this, the smart contract compiler will throw the error to mention you the version of the Solidity. So do keep in mind that whenever developing a smart contract, please mention the version of the Solidity. Next thing is like declaring the smart contracts. If you have first in the first line have mentioned the Solidity version, let's say Pragma Solidity version 0.4.2524. Next thing is the declaration of your smart contract name. So it will start with the keyword contract, because it's a Solidity contract, so you need to mention the name for it, because contract name could be my contract 1, my contract 2, my contract 3, my contract 4. Then we could move to like what are the keywords that are generally used in the smart contract development. Suppose you want to store a string value. So there are different data types available in the Solidity, which are like integer and address type and string type. So let's say we are looking to store any value that is related to the string. So we will make the declaration in this type, like string and the value name. Suppose you want to store any string value named string and then my name. So if you want to store your name, so you give the data type with the value my name. So it would be like from the starting, you have mentioned the Solidity version, and then you give the contract name, and then you define your data types that you are going to use in your smart contract. Suppose you want to add any other data types, so you could add on the next line and next line and next line, whatever your requirements is. Another thing, another important aspect of the like development of smart contracts is the constructors. So constructors, if you have studied in your C++, are very like very important part of any function. So whenever you want to take an input, whenever the function is initiated, you have to write the constructor and then write the logic inside that constructor, like what this constructor would be doing. Then to define a constructor, you have to write the constructor keyword. Before the previous versions, like before in previous version of 0.5.0, you just have to mention the name of the contract and the name of the constructor same as the contract name. Suppose your contract name is my contract 1, and then if you want to define a constructor, you have to define the same function name as my contract 1, but they have upgraded this thing. Now you just have to mention the constructor keyword, and then constructor will be defined. And each and every smart contract would be having just only one constructor. Not any smart contract could have like more than us one constructor. So it's like a very basic and necessary thing that you define the constructor only once in your smart contracts, or else it will throw error. So in this example, as you can see, we have defined a constructor which is of public type. So there are different types also which are available in Solidity. So we use these types with the functions. So there are four major types that are available. First is public, another is private, then third one is internal, and fourth one is external. So public, if you define the public keyword with any function, that means anyone across the smart contract, across the whole blockchain of Ethereum can access that function. And if you mention the function as a private, so you would have to access that function inside the smart contract only. No other smart contract can access to it. It's similar to something related to Java, where you mention the public and private category of the function, that this function would be accessible to private and this function would be accessible to public. Next thing we move is like creating modifiers. So what are modifiers? Modifiers are functions, or you could say a check that we use in our functions. So they add a very special behavior to a function. Suppose you want to make a function which will check every time that whenever a fund is transferred, the transfer is the transfer is made by the owner itself. The transfer is made by the owner itself. So in order to check that, you will define a modifier.
Sumit Patel, sir.
Yeah.
Sorry to interrupt. Can you restart the presentation? So there was an interruption.
Okay, okay. So I will start with this creating modifiers.
Yeah.
Yeah, so modifiers is like an addition to your functions. They act as an additional check to your functions. So whenever you want to add a very separate check to your functions, that when I want to check whenever a fund is transferred from one place to another place, the owner or the owner the we will define the modifier with the modifier keyword. So whenever you are writing any modifier, you will define the modifier with the modifier keyword and the name that you want to give that modifier. Suppose I'm building a modifier that checks every function that it is executed by the owner or not. So I will give this modifier name only owner, and then I will use the require keyword, which will check like whenever a message sender in the solidity means
Sumit,
whenever.
one second. Sorry for interrupting. Please maximize your screen or share your screen again. It's not visible to participants.
Which screen?
You just share your screen again. That's all. You go with your presentation. That's enough. It's audible, but it's
Uh-huh.
not visible. That's all.
Uh, s- could you see it clearly now?
No, sir. You stop the sharing
And again you start
share
sharing,
it
sir.
again, sir.
Okay, okay, just a minute.
Okay.
Is it clear now?
Yeah. It's we can see. Thank you.
Oh,
Sorry for
okay.
interrupting. I can go
Okay,
ahead.
okay. So whenever you are defining a modifier, you use the require keyword. So it will check that message sender is the owner itself or not. So if the message sender is not the owner, it will throw an error. So these are the modifiers that we generally use in any function of the smart contract. So you could define another modifier according to your needs. Suppose you want to check the function that whenever a transaction is made, it is made by a certain person or a certain address. So you will define modifier user A, give the modifier name user A or user B, and then inside the require statement, check with the message sender equal to user A, so that whenever you are making a transaction, it will check that user is not is making a transaction or not. If user A is not the person is who is making the transaction, then it will throw the error and it won't execute the transfer function. So the funds won't be transferred, because Ethereum blockchain we are dealing with cryptocurrency, and also we have to be very careful while dealing the functions and writing the smart contracts. So these additional checks are very necessary. So be careful while writing a functions and using it. Next is solidity functions, which I think I have already informed you previously. There are four major types of solidity functions: external function, and then internal function, public function, and private function. Modifiers add the additional check to the functions. And the another two types of checks that we have with the functions is the view and pure. So whenever you want a function that it doesn't changes its value, you will define the function only as a view. So let's say I defined a function as a function A and put an additional check that this function will be only viewed or set as view. So no other person could change the value. There are other concepts like function overloading and polymorphism and function overloading and inheritance that are used in the solidity. As I said that solidity is derived from the JavaScript and C++, so it inherits the capabilities of these two languages. Now I will come to the different function types. Internal functions are invoked inside the current contract only. Suppose you defined a function and you named as internal. So it can't be completed in different context, meaning that it can't be called from any other function or any other another smart contract. It will be called from inside the same smart contract only. And external functions can be invoked from the outside and through the transactions as well. So we use the external keyword with the function whenever we want the function to be public so that it's visible to everyone and any public could interact with it. Then we move to the private functions, which are like only visible inside the contract they are called in. Suppose I made a function b with any name, like function transfer funds or function initiate funds, and I named it the function as a private. So that function would be can be callable inside the contract only. Next one is the public functions. They are called from any place. Suppose I build a function that like fetches me the value or fetches me the address or fetches me the token balance of any public address on the Ethereum blockchain. So I will make that function public, and then I can access or anyone can access that function from anywhere just by calling it. Now let's move to the start development of the smart contracts. So we will use the remix ID in this case. So you can, as you can see the screen, this is the like remix.ethereum.org. This is the URL of remix ID where you could like go and start the development part. So once you open this, this type of screen will be opening it. I will introduce you the different components of this screen. So this is that button that you can click and it will create a new file. So we will start with a new smart contract and give the extension as a .sol so that my contract knows or my compiler knows that this is the solidity file and we have to compile it. Once I name it, you could see the solidity smart contract name coming in here. And this is the compile tab where you will see that all the uh, requirements or all the details related to the compile. So my current version is 0.5.1. If you want to change your compiler version, you could go to this drop down menu and select any compiler version. So they have available till 1.1, but I think no one uses 1.1 as of now. So I would suggest to use 0.5.1. So there are three options you could see. This is the first option is to auto compile. Suppose you write the smart contract you don't want to click this button again and again. So what you can do is check this auto compile key tab and it will auto compile the smart contract again and again. This is for the optimizations. And so whenever you have written the smart contract, now you want to optimize your smart contract, you could click on this tab. And third one is hiding the warnings. Warnings are those which suggest you to improve your smart contract. Let's say I am currently getting a warning that my source file does not specify required compiler version. Consider adding Pragma Solidity. So it's telling me or giving me a warning that I should add any version or to my smart contracts, which will start in a few seconds only. So once you have written down the smart contract, you could click on start compile or just keep clicked or auto checked this auto compile. So it will compile the smart contract and give you the output here. So we could see the console of this compiler in here. So whatever we will be doing, we will be able to see the whole like console thing in here. Next tab is Run tab. So Run tab helps you to select the type of environment in which you want to develop your smart contracts. Environment gives you like three different environments. First is JavaScript VM. JavaScript virtual machine is that will that is a type of local blockchain, you could say, that this IDE has. So you don't have to like connect with any other blockchain, and you could test in here only. It is very fast and helps you to reduce the time of development. It also provides you like five different accounts with 100 ether on each of the accounts. So you could like, you are never like on the deficient of this ether on your any of address. And this is the gas limit which is required for any transaction that you make. So three, this limit is being set as a default. You could change it according to your needs also. So if you want to make a transaction that happens very quickly, you have to increase the gas limit for this. And whenever we have compiled a contract, and if we want to interact with like any time later, we could just take the contract address and enter it here, and it will give me all the functions that were deployed at that contract address, so that anyone could see like which functions were there in this smart contract. So these are few checks that we have to make like according to our needs, such that the compiler makes the proper check for each and every transaction. So I think these two, three are useful for us. Now we will start with a like very small and basic smart contract that is that could be useful for us, or that would give you a proper introduction. So we will start with the like mentioning the version for this solidity. So we will give this name Pragma Solidity, and I will give my function name as 0.5.1. Now you could see this warning has been gone. There is no warning coming to mention my smart contract version. Now I will mention my smart contract name. So I started with the keyword contract, and I gave the name as instructor. So I will have given my contract a name, and here you could see that my compiler has compiled and told me that my contract name is instructor. Now I will define a data type for this instructor. My instructor will be having a name which is of string type, and then I will store its age, which will be of integer type. So this is the age data type, and then I will make use of the event. Event are the functions or the keywords in the smart contracts that helps you to know that a certain event has happened. So let's say if you defined an event whenever you wanted to transfer a function. So you made an event that whenever a transfer is made, please inform me or inform the front end or the browser that this transfer has been made. So we define that these events in those requirements. So I will define an event which will throw the output whenever an instructor is added, and I will name this event as an event. You could name it a separate or different one, like added an instructor or deleted an instructor or upgraded an instructor. So I will pass the data types, instructor name and instructor age. Now we will write a function which will be setting the instructor. We have defined the function and we have named the function as set instructor, so that anyone writing the smart contract can be well aware that what this function does. So anyone could know that this function is setting the instructor. Now we will pass the parameters. What we'll be having is a name and the age. So I have taken this name underscore name as a variable which will take from the user, which will be used to store or take the input value from the user. And this underscore age is also the variable for that, for taking the input from the. So I will assign my name variable, which I have given above here as underscore name, and then age equals to underscore age. So by this my function will come to know that whatever the name or age I enter will be assigned to these variables, so that they are very well aware, know that name is stored in this variable and age is stored in this variable. As you can see that there is a warning coming up like no visibility is specified. So I can set this function's visibility to public or private according to our needs. If I set it as a private, no other function or no one except this smart contract can access this. So I will give this name as a public because we need to interact with this function and insert or delete the details. And then I have written a function to set instructor. Now I will move to another function which is for getting the instructor. So I name this function as a get instructor, and no parameters will be passed for this. This will return a string type which would be the name for our instructor, and it would return the age which is of integer type. And what will be those variables is name comma age. Now our functions is complete. So if we haven't checked this, I can click on this button and it will be giving me few warnings that we can check with that later, or I could auto select this auto compile button. So I don't need to click this button again and again. It will keep on compiling. So as of now, we don't have any errors or warning. I will deploy it on the JavaScript VM. So this is showing me the constructor or the contract names that I have. So you can see that we have instructor name. I will click on deploy. So after clicking on deploy, we saw some activity in our console. So this when I clicked on this, there was a call went to the JavaScript VM, which showed the details that this transaction was successfully mined and executed. This is the hash, transaction hash, and this is the contract address, which is the unique identifier for this contract. From where this contract was executed, this is the my address 0x3a, which is visible in here 0x3a. Now you can see that some ether is also reduced. So as of now, you would be thinking like where all these ethers went. So this amount of ether went into the transaction. So from in here, you could see that this is the gas cost and this is the transaction cost. So this is the amount of ether that was deducted from my account. So these are the other different output that we get in this transaction. Now I have deployed successfully my smart contract. Now I want to interact with it. So here you could see the label as a deployed contracts, where you could see that I have a instructor smart contract which is same as we named initially. It has two functions. One is setting instructor and another is getting an instructor. So I am setting an instructor. Let's say I want to name an instructor as Sumit and age 25. So whenever I will be making this transaction, it will be storing the value. So this transaction is processed and this status is successfully mined to and from, and this is the input which you can see. This function took the two inputs, which was my name and my age. Now let's say if I want to get the instructor which I stored in the smart contract, so I will call this get instructor function and it will throw me the details. So first was the string data type, which was my name Sumit, and the another type is which is 20, like age, my age, which is of 25. So let's say I want to store another data which is Rohan, and it's of age 70, and then I will make a transaction. So this transaction also happened successfully. So you could see that the input taken here was Rohan and his age was 70. And if I click on get instructor, so you could see Rohan and his age is 70. So this is very basic smart contract which is used to, I would say, store and get the value. Now we'll move to a little much more complex smart contract, which would be like kind of similar thing. And then we would rename our smart contract as 2.solve. So we will start with the version. We will rename it, give the name to the contract, my contract. And then I will declare my data types that is necessary, because Solidity is very optimized language, so it will ask you to give the size. So I have selected here like integer which is of 256 bytes. It is of public type. I will give this name people count and I initialize it with the 0 value. Now I will declare a mapping which will be used to store all the people that I will be storing in this smart contract. This mapping would be type of public, and I will name this mapping as people. So what this mapping is doing is it is storing all the persons that we have, we will store in this smart contract. So it will keep an account of all the people that are stored in the smart contract. Now next I will use this data type which is of address. It will take the address values only. So address are represented by this 16-bit data. Then I would rename honor. Now we will move to defining the modifier. I will give this modifier a name as only honor. So it will check always that whenever I use this modifier, it's the only honor that is making the transaction or not. message dot sender equals to honor. Next, we will use the struct keyword or struct data type for the solidity for defining a person. So structure, if you have worked with the C++, there is a data type called structure. So it's similar to this only, which we are using in here. So we will define a struct which would have a name as a person, and then uint id, and then a data type with string name as a first name, and then a string data type with last name. Now I will define my constructor with a constructor keyword, and then give it a public visibility so it's visible and callable by everyone. Message dot sender is equal to function. We will define a function which is having add person. This add function will be taking the two variables or parameters. First would be the first name and another would be the last name. We will define the visibility to public and add the modifier so that only owner can add it. We will call another function inside it so it knows that we have to count the persons. Next thing, we would define a function. This function would be used to increment the count for each and every person that we add to our array. So we will name this function as increment count, and we will give this function a visibility as internal so that no other person could call it. We will make use of the shorthand operators. Now you could see that we are getting some error because we use the semicolon. Now you could say that our contract is available and ready to deploy. So we will use the deploy button. Now my contract is being deployed. Next, we can see that three functions are in here. So first is for adding any data that we want. So let's say I added my details to this function or this smart contract. It will make this transaction and store the value. Now I can see that people count is 1. 1 person is being stored. So if we store another person, transaction is being made and now the count has been moved to 2. Now the smart contract knows that this function has 3 persons. Now people count moves to 3. So if you want to fetch any specific person, you could enter the value or the key for that person. It will fetch you the details. So first we entered myself, my name, and in the second we enter this person details, and now third we have this person details. So this is the type of functions or smart contracts that we could deploy it and use it according to our needs. This is the local testnet that we use to deploy. If we want to use the Ethereum mainnet blockchain, we will use the injected Web3 version or Web3 provider. So we have to install a extension named MetaMask, so it helps to connect with our network. Here you could see all that local testnet that are being attached to it. So these 4 are the testnets, and one is named Ethereum blockchain. So if you need to deploy it, here is my address, and as you could see that it doesn't have any balance 000. So in order to make any transaction, you would need to have some Ether or some US dollars in it. But if you are making a transaction on any testnet, it would be like no requirement for I have some sample ETH or sample data I get from the faucet that I could test. So these are my previous transaction, as you could see. So if I want to deploy it on any testnet, I will select it from here, injected Web3. It is showing me that I have selected the Rinkiby test network, and then I will click on deploy. So MetaMask will ask for me to confirm that this is the gas fee and this is the total amount that would be deducted from your account. So once I click on confirm, it will take some time because it like approx 5 to 10 seconds to get confirmed. So as you could say that it's being confirmed, we could move to the Etherscan to get the details of this transaction. So this is the explorer of the Etherscan, which shows you all the details to, from, the value and the transaction hash of this transaction. So each and every time you make a transaction, you get this transaction hash, which is very unique to each and every transaction. So this is an overview, I guess, of like developing the smart contracts. So now I'm open to any questions or anything, any doubts that you have.
Participants, if you have any questions, in the chat box. Sumit, you can see the chat box. Questions, you can answer those questions.
Sorry?
Internal function.
Which one?
Difference between only one person we have, right?
Okay. Difference between the public and internal function, right? So public function, like whenever you declare any function as a public, you could access it from like across anywhere in the smart contract or from the different smart contracts. But like whenever you define a smart contract as an internal, you could only interact internally, like no from you can't interact it from the different smart contracts. So it is type of like limiting access to a function.
We have one more question. How can we use Ethereum for file storage? Any library we need to import?
Yeah, you could use like for like file storage, but like as I said, like if you have like a very hard like big amount of data, if you the file that you are storing is a like very big size, so it will cost you much more ether or the transaction fee which you have to pay ultimately, because if you are making a transaction then you have to get that. So there are libraries and there are other systems like IPFS or interplanetary file system where you could store the whole data like free of cost and then put the reference of that IPFS file in the Ethereum smart contract.
And we have it. Can you tell about the MetaMask?
Yeah, sure. So MetaMask is an extension that is used to connect with like as of now I don't have any Ethereum node running on my laptop. So I do need such any such medium that I could connect to the blockchain. So MetaMask is such an extension like it's available on the Chrome and Firefox both. So it's an extension that lets you to connect with like any of the networks on the Ethereum or testnet on main network.
Okay. One more question we have. Is it necessary to use MetaMask every time to run smart contract?
Like if you are using the local development environment, as I showed you, like this JavaScript VM. So if you are using the virtual machine in your local, you don't need the MetaMask then. But if you are making transaction on any other networks, let's say test network or main network, then you have to use MetaMask every time, and it's like very secure way to make a transaction.
Okay. When do we use internal and external keywords?
Internal like same internal is just used for like every function that is can be used inside the smart contracts, and if we want a function that could be accessed from outside the smart contract, then we defined as a function as external.
Some suggestions for a research scholar to use Ethereum.
There are like particular various fields because this is a very new field, so there are various topics that are like very popular in Ethereum. So like you could work on like scaling of blockchains, because there is like a time limit or a time that is taken by every transaction, so you could work upon that. You could work upon the file storage, so you could work upon the interoperability, like how could you interact between the two blockchains, and you could work upon the security of smart contracts, because a lot of smart contracts have bugs and errors. You could build some tool to check it. So these are few areas which a research scholar could like use the
For
Ethereum.
any projects for UG students, any idea?
Uh, Projects like you could build a very small app that could store any file or any text file, JSON file or image into the blockchain, and then you could like fetch it, or you could build a very small voting system on the Ethereum blockchain, because like the voting is very area that is needed to be researched and implemented in a proper way. So blockchains are very transparent in that case. You could use the Ethereum blockchain for building that, and the supply chain management and finance related projects or finance related areas.
Okay, okay. Sumit, it was a wonderful session, and almost all participants have an excellent feedback towards you, and it was really wonderful. From the
Thank
Department
you.
of Computer Science and Engineering, Vidyavardhaka College of Engineering, we wholeheartedly thank you for your commitment and time, sparing your valuable time, and accepting our invitation. Thank you so much, Sumit.
Thank you.
Participants, we shared the attendance form and feedback form. Kindly fill the form without fail, and it will be open for 20 minutes. Kindly fill the attendance and feedback form. Sumit, thank you so much.
Thank you. Thank you. Thank you.